What if you could build your own smart digital canvas, a frame that you can hang on your wall and update from your phone with any GIF or pixel art that you want? Well, today we're doing exactly that. We're turning a pile of wood, or rather, some really nice wood actually, but there's another story behind that, and some cheap electronics into this incredible custom Wi-Fi connected DIY pixel display. Stick around because you're going to want to build one of these. If you love DIY electronics and making cool things for your home, you're in the right place. So do me a quick favor and hit those like and subscribe buttons down below. It really helps the channel and you don't want to miss what's coming next. So what's the plan? Well, we'll start by building a custom wooden frame from scratch. Then we'll wire up the brains of the operation, a powerful ESP32 microcontroller, and the star of the show, a 16 by 16 NeoPixel matrix. Finally, we'll flash it with our custom software that hosts its own web page, letting us upload new art from anywhere on the network. It's a super fun woodworking and electronics project all in one. I've made all the files available for you if you want to build your own. It includes the INO file for the Arduino IDE, an HTML file for the internal web server, and JavaScript library file. And that's used for converting the GIFs into separate RGB images. And this means that because I've chosen not to use an online library, it's completely self-contained and future-proof as well. First up, the frame. I'm using some mahogany that I've kept since I was 13 years old. And today, it seems like the perfect time to cut off a little bit and make something out of one of these boards. You, of course, can use whatever you like. The key here is to create a channel on the inside of the frame where the matrix, the wiring, and everything can sit in, so it looks clean and professional when it's hanging on the wall. You could do this frame shape by cutting out a section of the wood at the back of a thicker piece, maybe using a router or something like that. I'm choosing to use my bandsaw and sander and then glue the parts together. So I'm just taking the corner off so that it looks nice, but it still should leave a little space down the bottom here. So that's the two parts of the frame glued up, and what I'm working on now is the square part at the back that will hold all the frame together and all of the electronics. Now for the fun part, the electronics. Well, the heart is this 16 by 16 NeoPixel Matrix WS2812B LED. That's 256 individually addressable RGB LEDs that we can control. The brain is this tiny powerhouse. It's an ESP32 dev kit. It's perfect for this because it has a built-in Wi-Fi and it's fast enough to handle the animations. I did start this project using an Arduino, but switched to the ESP32 when I wanted to add the ability to show GIFs, and came with the Wi-Fi and everything, which is all super cool. A little bit of sanding, a touch of wood glue, and some clamps, and we have our basic frame. It's looking good. You know, it's amazing how much of of this video is speeded up clips. I recorded lots of hours of sanding, cutting, but you know, I don't think that really helps the story of the build. If you want longer videos, let me know. But I think what I'm trying to do is give you the story of what it is and how I built it without too much of the repetitive manual tasks. So the finish I'm putting on here is just a boiled linseed oil. It's a really nice finish. It still keeps that kind of antique look. It doesn't put a big shiny plastic layer on top and allows you to still touch the wood while also protecting it at the same time. And it's quite safe for your hands. So it's the finish I really wanted to go for to give that contrast between sort of modern and antique. You know. Hopefully, I've done the mahogany some credit anyway. So this is just a bit of baking paper, which I'm going to use as a diffuser, and that will stop the LED or minimize the point of light where the LED is shining, and it will light up the whole square of the matrix rather than just the LED pinpoint of light. It makes the images come together a little bit more as you see the whole square lit up. It's an amazingly effective solution. You could also use some sandpaper on the back of the um, perspex to give the similar effect um, to shade in or diffuse the light. But the baking paper works amazingly well. So for anybody who's not made anything in Tinkercad, I can personally vouch that doing this kind of stuff, this 3D modeling to then print out on your printer, I spent so many months using only Thingiverse, and if I couldn't find it, I didn't print it. But it's really, really easy. It's like drawing on a piece of paper, but on your computer screen, or playing with Lego on in a 3D environment. It's really simple. You choose your shape, you make it a hole or a solid. Right here, you can see I'm making a 7mm hole in a tiny little box. It took me about 5 or 10 minutes to make this entire thing. You save it as an STL, save it to your printer, slice it in your software, and then that's it. So I've added in the 3 holes for the 3 buttons, and then I print it out. So if it's not for this particular project, don't be afraid to jump in and try and build your own stuff in using Tinkercad and then saving it to your 3D printer.
So I've got this printed out. I've just knocked off the corners so it's not sharp, with a little bit of sandpaper. And now what I have to do is just fit all of the components.
And the wiring is super simple. The buttons for the brightness and cycle speed, you just connect the GPIO pins to a common ground through the switch. And the most critical part is the power. You can't power the 256 LEDs from the ESP alone. You'll need a separate 5-volt power supply. And the key is to create a common ground by connecting the ground from the power supply to the ground on the ESP and the LED matrix. And that's super important, otherwise the buttons won't work. The data line from the ESP32's GPIO number 13 goes to the matrix's data in pin, and you can change any of this within the code as well. But this is just what I have it set up to. So the back box I've made here, just to cover all the electrics, is very low profile, and there isn't really enough room for a full DuPont pin on top of the board, so it would stick out too much. So what I've done is I heated them up a tiny bit and slipped off the plastic, and then I was able to bend over the DuPont pin. The connector pin just bent it over 90 degrees and it fitted nicely. With everything wired up, it's time to bring it to life with some code. So I'm using the Arduino IDE program to push the code to the ESP32. I've written a sketch that does everything. It connects to the Wi-Fi, runs a web server, and controls the LEDs. We also have a special data folder with an index.html file and the JavaScript library. And it's really simple to upload that to the ESP32 using the Sketch data upload tool to put those files onto the built-in memory. This is what creates our web interface. You can copy and paste the code from my online setup guide into your Arduino IDE app, change the Wi-Fi password and your SSID here in the code, click send, and literally there's nothing more to it than that. Okay, so moment of truth. Let's upload the code and see what happens. First, a beautiful startup sequence to test all of the LEDs, and it goes from top left to bottom right. The IP address is also set to scroll across the screen, and if the Wi-Fi isn't available, it just would say no Wi-Fi. Now, from my phone or just a browser on my computer, I can open a browser, go to the IP address that's shown on the screen, and here we have our control panel. Let's upload our first image. So let's choose this little heart. I'll select it and then click upload and process. And just like that, it's on the display. Now for a real test. Let's try an animated GIF. And there it is, a little doggy. And let's upload that. A fully animated GIF running on our custom built frame. Absolutely fantastic. But it gets better. I've added 3 buttons for physical control. This one changes the brightness up, this one changes it down, and the change is instant. And my favorite button, this one changes how long each picture is displayed. And you can see it scrolls the new time right on the screen, 5 seconds, 10 seconds, 30 seconds. And this makes it a perfect hands-off digital art frame. And there you have it, from a couple of planks of wood and some off-the-shelf electronics to a completely custom, smart, Wi-Fi connected pixel art display that I can hang on my wall and update from my phone. This was such a rewarding DIY project, and the final result is just awesome. I couldn't be more proud. If you want to build one for yourself, I've put a link to the complete setup guide with all of the final code in the description below. Let me know in the comments what you would display on yours. And if you enjoyed this build, do me a huge favor and hit that like button. And be sure to subscribe and ring the bell so you don't miss the next project. Thanks for watching.